Good afternoon, guys. Welcome back into my channel. So in this lecture and lab, we're going to understand and configure HSRP. So this is another Cisco PDF format book that I will provide a link of it below for you. You could have it for free. So it talks about like understanding the HSRP. So HSRP, which stands for Hot Standby Redundant Protocol, is a Cisco standard method to providing high network availability by providing first hop redundancy for IP hosts on a IEEE 802.LAN configured with a default gateway of IP address. So HSRP routes IP traffic without relying on the availability of any single router. It enables a set of router interface to work together to present the appearance of a single virtual router or a default gateway to the host of a LAN. When HSRP is configured on a network or segment, it's provided virtual media access control address and an IP address that is shared among a group of a configured router. HSRP allows two or more HSRP configured router to use the MAC address, an IP address, an IP network address, or of a virtual router. The virtual router does not exist. It represents the common target for routers that are configured to provide backup to each other. One of the routers is selected to be the active router and the other to be standby router, which assume control of the group MAC address and IP address should be designated active router failed. So note, routers in an HSRP group can be any routers interface that support HSRP, including Catalyst 3560, routed port and switch virtual interfaces. So these are different articles that you could come and look. This is an architecture of an HSRP. This is multiple HSRP. So like I said, I'm gonna leave this. I'm gonna leave. So default HSRP configuration, HSRP group default non-configured standby group number 0, standby MAC address. So HSRP configuration guidelines and stuff like that, enable HSRP. So standby and different things like that. So let's take a look at it. Like what do the CCNP and core book says about HSRP. So it says HSRP stands for router protocol. Hot standby router protocol. Hot standby router protocol is a Cisco proprietary protocol that provides transparent failover of the first hop device, which typically acts as a gateway to the host. HSRP provide routing redundancy for IP addresses on an Ethernet network configured with a default gateway, so it's the same. So note, the HSRP does not support preemption by default. So when a router with lower priority becomes active, it does not automatically transfer its active status to a superior router. So HSRP enable interfaces and enable interfaces, send and receive multicast UDP-based HALO messages to detect any failure and designate active standby router. If a standby device does not receive an HALO message or the active device failed to send an HALO message, the standby device with the second highest priority becomes HSRP active. So these are pretty much interesting topic that you will have this link of those books in the bottom of the page. In the bottom of this video. So it is possible to create multiple HSRP instances for the same instance. Some network architecture configure half of the host for more instance and the other half of the host for a second instance. Setting different priorities for each instance makes it possible to load balance the traffic across multiple routers. It's the configuration. So let's go ahead and pull up the little Word document lecture that we prepared. So understand hot standby routing protocol, HSRP. So this is a little small architecture on it. So it says that redundancy is a key factor for any modern network. You just can't afford to stay without the network even for a few hours. However, your network device will fail one day. It might be the next month or within 5 years, but at some point, something will just stop working. If you don't want your business to stop working too, you better add some redundancy. Since all of your devices point to a default gateway, if that fails, they will stop communicating outside. The hard standby routing protocol, HSRP, allows a secondary router to take over the role of the default gateway in case the first one failed. In this article, we will see how it works. Now, the need for HSRP. So the problem, when a device comes up, it either has a static IP address or a query for a DHCP server for a dynamic host configuration protocol to provide an IP address, such like a laptop, if you're connecting the Wi-Fi, if you're not wired or whatever. Now, no matter what's the case, the device would have an IP addresses and subnet mask and the address of its default gateway. Now, unfortunately, the majority of devices can store a single IP address for the default gateway. As a result, if the gateway fails, they will simply point to a black hole. They won't be able to communicate outside of the network. So if the default gateway fails, you will have a major outage. So the router is a single point of failure. Now, this is an architecture of a default gateway single point of failure. If the router failed, the entire network will be isolated. You can also see that if a switch failed, the computer connected to it will be isolated. So while it is unpleasant even the switch is not a single point of failure, this is because their failure does not impact the entire infrastructure, only part of it. However, in case you are connecting servers in a data center, you want to connect a server to 2 switches at least. Now, the solution, your network should have no single point of failure. And HSRP helps in that sense. The first thing you need to do is purchase another router and another internet connection. Since we have no way to tell a client to use multiple gateways, we need to find a workaround. We do that by configuring the two routers with HSRP. Instead of telling the clients, we prepare the secondary gateway to mask itself as the primary one. If the primary fails, more or less, we are lying to client about which router is the default gateway. To do that, to do that configuration, you add a virtual IP address on both routers. By default, only the primary router will be used. However, if the primary router fails, the secondary will start using the address. So it's the active virtual gateway, and they go internet 1 and internet 2. So this network implements redundancy by using a virtual gateway. The VIP is dedicated IP address. You can make all your device point to that address as default gateway, and you do the trick. In case the first router failed, the second one will start being the default gateway. Now, understanding HSRP, the first hop redundancy protocol family, the hot standby routing protocol is the first of the first hop redundancy protocol, which is HSRP family. It is a Cisco proprietary implementation, easy to configure and troubleshoot. In the same family, we will find the virtual router redundancy protocol, which is VRRP, which is a standard, and the gateway load balancing protocol, which is GLBP, and another Cisco proprietary implementation. So all of those protocols have the major goal of default gateway redundancy. However, they slightly differ in features and implementation. HSRP and VRRP work almost identically. The major difference is that VRRP is standard, GLBP adds some load balancing feature. It put in place a trick that allows some client to use a physical router, and some other clients to use the other. As a result, you load balance over your LAN. It might seem the most optimized one, but if you have STP in place, it will force your traffic on the same link, making load balancing ineffective. So guys, the component for HSRP, so says you can configure multiple routers to share the same HSRP virtual IP. However, the only one of them will be active in a given moment. So nonetheless, all must understand that they are sharing a virtual IP and must talk with each other. So to do that, they communicate using the multicast address, which is 224.0.0.2 HSRP version 1 and 224.0.0.102 HSRP version 2. This is very important in case if you were to ask this question in a job interview. So in this communication, routers evaluate some keys, some key element to define who should be the host of the VIP. So the router that is forwarding traffic for the VIP is called active, while the other one is a standby. So HSRP group number, unidentified, or just, so I tell you what, guys, so for the purpose of not making this video too long, you could go ahead and take a look at this yourself. Just pause the video and read over it, joining the HSRP groups. meaning cooperation. Routers must talk with each other and understand the parameters. If they don't interoperate correctly, you might have two routers believing to be active at the same time, which will not be good. So as a result, the switch will see the MAC address in two places and believe it is a duplicate. Within seconds, the interface will start to flap, creating a high instability. So no, guys, so like I said, so enough talking. Why don't we go ahead and pull up? It didn't prepare packet tracer yet. So why don't we go ahead and pull up packet tracer and start this lab configuration today for the HSRP. Go ahead, pull that, and start this lab. Okay, guys, so it's coming up. Okay, let's do this. Let's make this apart from each other. Right there. Let's make this here. Let's grab the other one. Right there. Let's make this. Start posing from each other. Okay. See if we make this big, if there will be a problem. Let's go ahead and pull this a little bit. So we have the assignment here says to HSRP configuration guide. So the addressing table, they go it on water 1, water 2, and water 3, the INET, the HSRP virtual gateway, switch 1 and 3, PC, whatever. So the objective says that in this whatever, so we're going to configure the HSRP active router and configure the HSRP standby router and they verify the HSRP operation. So that's what we'll be doing, okay? Okay, so first thing first, let's go ahead and do, so on step 1, we're going to verify the connectivity. We're going to trace the path to the web server from PCA. So there go PCA, let's pull up a browser. Let's ping 9.165.200.226. Oh no, it's not pinging, it's trace work. So let's open. Let's do tracer. So it's tracer. So we do. So we're gonna do the tracer command, which we did, and then which device on the path from PCA to the web server. So using the addressing table, so you could see that it's router 1, 2, and the INET. So now, on step 2, we're going to trace the path from the web server to PCB. So why don't we go ahead and just grab this, if we can copy it. Let's grab PCB, command, and let's see if we can paste it. Yeah, and let's see. Now, if you observe the network behavior from router 3, it's become unavailable. So we could select and delete tool for the packet tracer toolbar and delete the link between router 3 and switch 3. Router 3 and switch 3. Oh. And then you could do skip. Then let's try now. Now we're going to open the command prompt and then start do the same. But see what we get here. So let's go ahead and try that again. Let's try it again. So we compare the current output with the output on the command on the second step. So now the traceroute command cannot determine the path from the web server because the path has been broken, right? So now, if we click the connection icon in the lower below, repeat, call it the PT window, locate the copper straight. So let's go ahead and connect this cable back. Just straight through cable. Start from here to there. Okay. So after the link, let's try to ping from here to the, see? Now we should get a connection. Let's see. I try to do that again. Let's see if we have any connection yet. So we do. Of course we do. So now let's see if we can ping it instead of trace it, I mean, ping. So we have a successful ping. Okay. So now on router 1, we're going to configure HSRP on gigabit Ethernet 0/1 for router 1. So let's go ahead. Let's go to add conf t. We could do NFS, I mean gig 0/1. Let's move this, make this 0/1. And then we could specify the HSRP protocol version number. So the most recent version number is 2. So we're going to, I mean, the standby version only support the IPv4 addressing. So let's do standby. Sorry, guys. Standby version 2, right? So configure the IP address on the virtual default gateway. This address must be configured on any host that require the service of the default gateway. So it replaces the physical NFS addresses of the router that has been previously configured on the host. So multiple instances of HSRP can be configured on a router. You must configure the HSRP group number to identify the virtual interfaces between routers. In a HSRP group, this number must be consistent between the routers in the group. So the group number of this configuration is 1. So on router 1, we're gonna use this IP address that we've been provided. That's that 168.1.24. This IP. It's this one that we're using. So let's use that. So let's configure the virtual. So we're gonna say standby 1 IP and paste that. Right. So now they designate the active router for the HSRP group. It is the router that will be used as the default, as the gateway device unless it fails or the path to it is become inactive or unstable. So we're going to specify the priority for the router interface. The default value is 100. A higher value will determine which router is the active router. If the priority of the router in the HSRP group are the same, then the router with the highest configuration IP address will become the active router. So let's go ahead and do standby 1 priority 150. So now router 1 will operate as the active router, and traffic from the two lanes will use it as the default gateway. If it is desirable that the active router resume that role when it's become available again, we can configure it to preempt the service of the standby router. The active router will take over the gateway role when it's become operable again. So let's go ahead and do standby 1 preemptive. Let's take it, preempt, not preemptive, preempt. Now, question, what will the HSRP priority of router 3 be when it is added to the HSRP group 1? Well, the answer is 100, which is the default value. Now, we can configure the HSRP on router 3. So let's go ahead and configure it for router 3. So it's the same step. We're just gonna make it faster than these, because we wanted to explain as we do it. Conft. So then what do we have? Gigabit. It says it. Gig. So then so we could do standby version 1. Then we do so we could do the standby. So So state is standby. So instead, the state is standby 2. Then we can do standby version 2. Then we could do standby IP. Which IP we using? The same IP. Up. Then we could use standby 1 priority 150. No. So that's basically for router. We don't need this comment for priority. Okay, so this is it for router 2. Now with switch 1, gotta make our own configuration too. So conf t, we could say IP default gateway and use this IP address. And now we do so and conf t IP default, IP default gateway, paste this IP. Okay, so let's go ahead and grab it. It's the IP address of this HSRP virtual gateway. O dash bang. Okay. We should change the default gateway on PC-A and PC2, and that'll be the end of this lab. Let's go here. Let's go on desktop. What's this? Oh, we gotta close this first. Not desktop. We should go on config, IP config. So let's change the default gateway here. These, the same IP address we have. So let's just paste this and see if it'll take it. Bingo. And that should be it. Then we go there, we close up, sorry. Let's remove this, we close this, we go here, and we remove the default gateway, and then we paste this here too. So that's pretty much all that we gotta do. Now say if we were to ping from here, if you wanna ping this IP address, so ping 49.165.200.226. See if we get a ping. So we good. Well, guys, thank you so very much for following along. That's all that we had to do in this lab configuration. So in this lecture, we configure, we try to explain to make you understand what is HSRP, what is its use, why is it so important to configure HSRP in your network. And we configure it, and then we verify. So let's verify it, by the way, because that was part of the lab that we was gonna miss. So let's say So show standby command. So do show. Oh, how about we just end this? Say show standby. This water is big and so we have it. So it says statistics. What do we have here? So it's going water 2. Oh, so it's on these 2 routers. So in water 1, water 2. So standby. Water 3. So let's say conf G. So if we could say an opal. All right, guys. So thank you so much for following along with me. Stay tuned for another lab.